binomials when the a value, so the number in front of the x squared, is not 1. But on the front of this worksheet, I put, and again, this is posted on Google Classroom, just a little flow chart of kind of the questions you want to ask yourself as you're going through and you're factoring something. So you always want to first check for a GCF. That's always where you begin. And then after that, you're going to ask yourself, how many terms do we have? So if you have 2 terms, you want to check, could this possibly be a difference of 2 squares? Okay, so are each terms a perfect square? And then 3 terms, which is what we're going to be talking about now. And you don't really need to worry about 4 terms right now because we haven't really discussed factor by grouping, and we won't be, so you don't need to worry about that. All right, I just want to go over these 2 examples in the front. These are just going over factoring completely, which was the previous lesson. So let's look at the first question, 81x to the 4th minus x to the 8th. Oops. So the first thing that we always want to do is check to see, do we have a GCF? So in this case we do, and it's going to be x to the 4th. Now the reason that it is x to the 4th is because that is the lower exponent. Okay, so I don't know if you remember from the previous lesson, but when we're taking the GCF of variables, we always take whoever has the lower exponent. So now we're going to divide each one of our pieces by our GCF, which is x to the 4th. Okay, so now here the x to the 4th and the x to the 4th cancel out, reduce to 1, and we're left with 81 minus, and now over here we're going to subtract our exponents, so 8 minus 4 is 4. So right now we are left with 81 minus x to the 4th. And to actually finish writing that in factored form, you just have to remember that you need to put the GCF on the outside, okay? Because remember, that part did not go away, it just was pulled out to the front, okay? All right, so now we want to ask ourselves, can we go even further? Can we factor this even more? So you'll notice that we have 2 terms, and so I'm kind of thinking like, okay, could this be difference of 2 squares? So if you think about the 81 and the x to the 4th, well, both of those are perfect squares. So the square root of 81 is 9, and the square root of x to the 4th is x squared. Okay, because when you take the square root of a variable raised to an exponent, you just divide the exponent by 2. Okay, so now I'm going to go over here and I'm going to write down what we get when we factor the 81 minus x to the 4th. So we've got our double bubble. Now the 9 goes in the front of each bubble because the 81 was the first term, and then the x squared goes in the back of each bubble, and 1 plus and 1 minus. And don't forget the x to the 4th from the beginning is still a part of the problem. Okay, so you have to include that. Make sure you bring that down. Now at this point, I'm looking at this and I'm actually kind of thinking like, could I go even further? Because I'm looking and seeing that I have actually 2 binomials, and if you look carefully, the second one is a difference of 2 squares. So we can actually go even further on this one. This is a pretty challenging one because there's so many steps. So the square root of 9 is 3, and the square root of x squared is x. So now to factor this, we have our double bubble, 3 in the front of each bubble, and x in the back of each bubble, 1 plus and 1 minus. Okay, now you may be asking yourself, why can't we also do that with the 9 plus x squared? Well, this is difference of 2 squares. So if I'm doing 9 plus, that is not difference, that's sum. So we can't do that with this. Okay, so this guy is completely factored. So we just bring him down, he's still part of the answer, and we still bring down the x to the 4th. So this whole long thing is actually our final answer. Okay, that is now completely factored, and yeah, this one's a pretty long problem, but just take it one step at a time. And I think I'm actually going to skip this one only because I want to get into doing the harder factoring problems. So when I say harder, what I mean is that the number in front of the x squared, which is your a value, is going to be something other than 1. So before this lesson, you've only seen factoring when something looks like this. So let's say we've got x squared plus 5x plus 6. Okay, so far you've only seen trinomials where the leading coefficient is 1. So now we're going to be dealing with problems where the leading coefficient is going to be something other than 1. And so for this, we're going to learn something called slide, divide, bottoms up. Okay, so I have the steps written out for you here. Okay, but I'm going to go through the problem and explain what each one of the steps means. So for example number 1, factor 2x squared minus 5x plus 2. So slide, divide, bottoms up. So the first thing you're going to do is take the coefficient of the x squared, which is 2, and you're going to slide that to the back and multiply it by the last term, which in this case is also 2. So now I've moved that to the back, so now we're dealing with x squared minus 5x plus, and then 2 times 2 is 4. Okay? So now we're just going to factor, let me just erase this little, there we go. Now we're just going to factor this the way that we've normally factored a trinomial. We're looking for two numbers that are going to add to 5 and multiply to 4. Okay, so our factors of 4 are 1 and 4 and 2 and 2. So the pair that's going to make the 5 is the 1 and the 4. Okay, so we've got x and x, 1 and 4. And then the signs that are going to make that negative 5 in the middle are going to be 2 negatives. Okay, so now we need to get to the divide bottoms up part. So now that you've done this factoring, I'm actually going to rewrite it up here. Just leave a little bit more room. Okay, so now for the part that says divide. So now we're going to take in each one of our bubbles the number and divide it by 2. Now the reason we're dividing them by 2 is because that's the number in the beginning that we did the slide with. Okay, so now with x minus, now this is 1/2. Now 1 divided by 2 does not come out to be a nice integer. So this is where we do the bottoms up. We're going to bring the 2 in front of the x. So this becomes 2x minus 1. Okay, and then here, well, 4 divided by 2 works out nicely. It's just 2. Okay, so your final answer is this, 2x minus 1 times x minus 2. That is, so this answer right here is this original problem in factored form. And you can always check by multiplying this out, which we did that at the beginning of the year. That's when we do the box method. Okay, and you would put the 2x minus 1, the x minus 2, and multiply it out. So that is what slide, divide, bottoms up is. Okay, and this down here goes through the same example, same steps. So we're going to just do a few practice problems. Now I have a lot of problems in this packet. We're just going to go over a few of them together. Okay, so number 1 on the next page. So 3x squared plus 10x plus 8. Okay, so first thing, we're going to take our 3 and slide it to the back over by the 8 and times it. So now what we have is x squared plus 10x plus 24. Okay, the 24 is from the 8 times 3. So now I'm going to list my factors of 24. Okay. And remember, you can do this by going into the y equals of your graphing calculator and you could type in 24 divided by x. And then if you go into the table, that'll give you your list of factors. You would start at +1, okay? And I have the links up for you on Google Classroom to the online graphing calculators. So back to my list. So 3 and 8 and 4 and 6. Okay. So now you want to ask yourself which pair of factors can somehow come together to make the 10 in the middle. So that's going to be the 4 and the 6. Okay, so now we'll do our double bubble. So x and x, 4 and 6. Okay, and now we need to figure out, well, what are our signs going to be? So I'm going to go over to the side and list my 4 possibilities of what the signs could be. And figure it out from there. So +4 + 6 is +10. +4 minus 6 is -2. -4 + 6 is +2. And -4 minus 6 is -10. So we were looking for +10, which means that that's going to be the first guy right here, which means both of these are going to be pluses. Okay? All right, so now we need to do divide and bottoms up. Okay, so now the number that we're dividing by is going to be the 3, because that was the number that we had to slide in the beginning. So divide each one of these by 3. Okay, now 4 divided by 3 does not come out to be an integer. It's 1.3 repeating, which is gross. So we are going to take that 3, and that's going to be our bottoms up. So we get 3x plus 4, and then here we get x plus 6 divided by 3 is 2. Okay, and that's your answer. Okay, now I just want to mention that you can actually do these problems without doing slide divide bottoms up. You can try to figure them out just from the beginning to factor kind of the regular way, just keeping in mind that you have an a value that's not 1. That's entirely up to you if you want to do it that way. There's no special trick for that, but I'm going to keep going with this way. All right, so let's look at number 2. So now 2x squared plus 7x plus 6. Slide our 2 to the back times 2. Okay, and now we've got x squared plus 7x plus 12. Okay, so now we want to find two numbers that are going to add to 7 and multiply to 12. So our factors of 12. Okay, and we're looking for the pair of factors that can somehow come together to make a +7, which is going to be 3 and 4. And let's list our possible signs. So +3 + 4, +3 - 4, -3 + 4, -3 - 4. Okay, so +3 + 4, that's +7. This is going to be -1. This will be +1, and this will be -7. So we were looking for +7, which is our first one right here. Okay, so now we'll go over here. So we have x and x, 3 and 4, and we already know that both signs are going to be plus. Okay, so now we're going to do the divide bottoms up. So we're going to divide each one of these by 2. Okay, now the 3 divided by 2, that's not an integer, that's 1.5, so we don't want that. I'm going to bring the 2 to the front. That's our bottoms up, so 2x plus 3. And then here, x plus 4 divided by 2 is just 2. So there you go, final answer. Okay? All right. Let's do a few more. I'm not going to do the entire package because there's a lot of questions and it's really very repetitive. It's really just the same procedure over and over and over again. But if you're still really stuck, we can do a Zoom lesson and go over whatever you'd like to go over. I think I'm actually going to skip this page and maybe go to the next ones. Or not. Actually, you know what, let's do 7 and 8 just because those have different coefficients that we haven't, leading coefficients that we didn't deal with before. Okay. Alrighty, so number 7. 4x squared minus 9x plus 2. Okay, so first, going to take our 4, slide it to the back. Okay, and times it in the back. So now we've got x squared minus 9x plus, and then 2 times 4 is 8. Okay, so now we want to factor the x squared minus 9x plus 8. So we're looking for 2 numbers that will add to 9 and multiply to 8. So our factors of 8 are 1 and 8 and 2 and 4. And the pair that will come together to make the 9 is the 1 and 8. So we've got x and x, 1 and 8. Okay, and now we just need to figure out what are our signs going to be. So plus 1 plus 8, plus 1 minus 8, minus 1 plus 8, minus 1 minus 8. Okay. So positive 1 plus 8 is positive 9. 1 minus 8 is negative 7. Negative 1 plus 8 is positive 7. Negative 1 minus 8 is negative 9. So we were looking to get negative 9. So that's the bottom one down here. So that means both of these are going to be minus. Okay, and now we need to do our divide bottoms up. So dividing each one of these by 4, because that was the number in the beginning that we did the slide with. Now here, 1 divided by 4 is not an integer, so we bring the 4 to the front. That's our bottoms up. So this becomes 4x minus 1. And then 8 divided by 4 is 2, so x minus 2. And this right here is our final answer. Okay? All right, let's do one more together. And then hopefully you can try some of these on your own. So number 8, 6x squared plus 11x minus 2. Okay, so let's pick a different color. All right, let's bring the 6 to the back. All right, so now we've got x squared plus 11x minus 12. And now we're looking for 2 numbers that will add to 11 and multiply to 12. Okay, so list our factors. So looking at our pairs, if we want to find the pair that's going to somehow come out to be 11, that's going to be the 1 and the 12. Okay, so x and x, 1 and 12. Let's go over here and figure out what our signs are going to be. Okay, so this is positive 13, this is negative 11, this is positive 11, and this is negative 13. So it's going to be this guy right here because we want positive 11. So minus 1 and plus 12. And now it's time to do our divide and bottoms up. So we're going to divide each one of these by 6. So here we are doing our bottoms up, and we get 6x minus 1. And then here, 12 divided by 6 is 2. So x plus 2. And there you go. That's your final answer. Okay, so if you have any more questions, send me an email, send me a remind. We can do a Zoom or a Google Meet, and we will get all of this figured out. Okay? All right, thanks, guys.